Imagine a structure so vast it dwarfs galaxies, a cosmic skeleton stretching across the entire observable universe. Yet most people have no idea it exists. This isn't science fiction, it's the cosmic web, and what scientists are discovering about it, or perhaps what they aren't telling us, could fundamentally change our understanding of everything. Because at the heart of this unimaginable superstructure lies a secret that might make us question our very place in the cosmos. To truly grasp this profound mystery, we need to strip away our earthbound perspectives and look at the universe as a whole, not just isolated planets or even individual galaxies. For decades, astronomers believed that galaxies were spread relatively uniformly across the cosmos, like sprinkles on a giant cosmic cupcake. But as our observational tools grew more powerful, a more intricate, almost biological pattern began to emerge. What we started to see was a universe not of isolated islands, but of interconnected filaments, dense knots, and vast, empty voids. This sprawling network, composed of galaxies, gas, and an even more enigmatic substance called dark matter, is what we now call the cosmic web. It's the large-scale structure of the universe, and it's mind-boggling in its scale. If you could zoom out far enough, you'd see a honeycomb-like pattern with superclusters of galaxies clumping together along invisible threads, framing colossal, empty regions where almost nothing exists. It's like the universe itself has a neural network, a cosmic brain. But how did such an incomprehensibly vast and complex system come to be? And what, if anything, is operating within its intricate scaffolding? The answers, as you'll soon see, are far more unsettling than simple scientific discovery. The story of the cosmic web begins with the Big Bang. In the moments after this cataclysmic event, the universe was a hot, dense, and remarkably uniform soup of particles. But uniformity, especially on such a grand scale, is never truly perfect. Tiny quantum fluctuations, microscopic ripples in the fabric of spacetime, created infinitesimal differences in density. Over billions of years, gravity began to amplify these tiny irregularities. Where there was slightly more matter, gravity pulled in even more, causing these regions to grow denser. Conversely, areas with slightly less matter became even emptier. It was a slow, inexorable process of cosmic segregation. Dark matter, a mysterious substance that interacts only through gravity and makes up about 27% of the universe's mass, played a crucial role in this process. It provided the gravitational scaffolding upon which ordinary matter, the stuff of stars and galaxies, could accrete. Imagine an invisible spiderweb drawing in dewdrops. The dark matter formed the strands and knots, and then ordinary gas and dust flowed along these gravitational highways, concentrating into the glistening galaxies we observe today. These galaxies then clustered into groups, which aggregated into larger clusters, and these clusters, in turn, were drawn together along the filaments of the cosmic web. The voids, those immense swathes of empty space, are the regions where matter was pulled away, leaving behind ghost towns of the cosmos. This intricate dance of gravity, dark matter, and ordinary matter gave birth to the universe's largest structure, a cosmic tapestry billions of light years across. But as astronomers mapped more of this web, they started to notice something deeply unsettling. There were movements, massive cosmic flows, that simply didn't make sense within the established models. Something was pulling, something immense and unseen, lurking just beyond our cosmic horizon. What if this wasn't just a passive structure? What if something was using it? The first hint of this deeper mystery emerged in the 1970s and 80s with the discovery of what became known as the Great Attractor. Astronomers observed that our own Milky Way galaxy, along with hundreds of thousands of other galaxies in our cosmic neighborhood, wasn't just drifting randomly. They were all being drawn towards a single superdense region of space at an astonishing speed of hundreds of kilometers per second. It was like a cosmic river, with countless galaxies flowing towards an invisible drain. This attractor was initially thought to be a supercluster of galaxies called Norma, but even Norma wasn't massive enough to explain the observed gravitational pull. The sheer scale and magnitude of the Great Attractor implied an immense concentration of mass, far greater than anything we could directly observe. It was a gravitational anomaly, a massive unseen hand shaping the movement of entire galactic clusters. This discovery shattered the previous understanding of a relatively uniform expansion and introduced the terrifying thought that our entire galactic neighborhood was being pulled by something monumental, something largely unmapped and potentially unknowable. Fast forward to 2014, and the mystery deepened with the mapping of our local supercluster, a vast assemblage of galaxies, including our own. Scientists, using thousands of galactic velocities, meticulously traced these cosmic currents and found that our Milky Way is actually part of an even larger, interconnected structure they named Laniakea, meaning immeasurable heaven in Hawaiian. Laniakea itself is effectively a massive node within the cosmic web, comprised of roughly 100,000 galaxies spanning over 500 million light-years. And guess what? Laniakea is also being gravitationally attracted towards something even larger, a super-attractor that acts as the ultimate destination for all the galaxies within this colossal structure. The Great Attractor wasn't the end. It was just a stop along an even longer gravitational current. This hierarchical structure, this flow within flows, suggests an almost fractal complexity to the cosmic web, with gravitational influence extending far beyond our previous calculations. What if this wasn't just a simple gravitational pull from a dense region, but something more deliberate? What if the cosmic web is not just a framework, but a conduit, and Laniakea, our home, is merely a tributary flowing into some even grander, more incomprehensible system? The implications are staggering, pointing towards an unseen influence orchestrating the very dance of galaxies itself. And what was discovered next only amplified the profound sense of disquiet, pointing to an external force that challenged fundamental laws of physics. But the true enigma of the cosmic web, the phenomenon that truly sent chills down the spines of cosmologists, emerged with the concept of dark flow. In the mid-2000s, scientists studying the cosmic microwave background, CMB, the faint afterglow of the Big Bang, noticed something inexplicable. The CMB itself appears largely uniform, a relic of a time before the cosmic web fully formed. However, there are tiny temperature fluctuations within it. By analyzing these fluctuations, astronomers could map the large-scale motion of galaxy clusters. What they expected to see was random motion, albeit influenced by local gravitational effects within the cosmic web. Instead, they found that hundreds of galaxy clusters, located across a vast region of the observable universe, were all moving in the same direction at incredible speeds, hundreds of kilometers per second, relative to the CMB. This was not explained by the gravity of any known structures within the cosmic web, no matter how large. It was as if our entire observable universe was being dragged or pulled by something immense and unseen, coming from outside the observable universe itself. Imagine a cosmic current so powerful it carries entire superclusters, a silent, invisible river flowing towards an unknown destination. This dark flow defied conventional cosmological models, challenging the very foundation of how we understand the expansion of the universe and the forces at play within it. It hinted at the existence of structures or even entire universes beyond our cosmic horizon, exerting a gravitational influence that we can detect but not see. Some theories propose that it could be the gravitational pull of matter from a universe adjacent to our own, or perhaps a remnant of an even larger, primordial structure from before the Big Bang itself. What if the cosmic web isn't just a passive structure, but a network designed to channel this dark flow from a reality we cannot comprehend, a current that carries galaxies, like cosmic plankton, towards an ultimate unknown harvester? The sheer scale of this phenomenon, the fact that our entire observable universe appears to be part of a larger, directed motion, raises profound questions about our cosmic independence. We are not just adrift in space, we are part of a colossal, unseen river, and we have no idea what lies at the end of its mysterious journey. To this day, the mysteries surrounding the cosmic web, the Great Attractor, and the dark flow remain largely unsolved. We are part of a structure so vast it defies imagination, a cosmic skeleton that likely plays an even more profound role than we currently understand. What else might be hidden within its intricate filaments and voids? Could there be even larger, more complex structures operating on scales we can barely conceive? The very fabric of our universe, our home, might be merely a single thread in an unimaginable tapestry woven by forces beyond our comprehension. We peer into the vastness, finding only more questions, more unsettling hints of truths that may forever remain just beyond our grasp. The cosmic web isn't just a scientific discovery, it's a cosmic riddle, a testament to the fact that the universe holds secrets far stranger and more profound than we can ever fully grasp.